What goes up must come down, and then go back up again. Let's get to work. What's up, people? MisterToolbox back with another Amazon Lumberyard video. Buckle up. Today we're going to delve back into C++. We're going to build on what we learned last time with the empty component, and we're going to make one that actually does something. Once we're done, if everything worked out all right, what we'll have is a physics component that will make an object, a rigid body object, oscillate vertically. So let's get started. As was foretold in videos of old, our first stop is a project configurator. So we're going to create a new project. Go ahead, click Create New. We're going to call this Rigid Oscillator Test. Go ahead, click Create Project. Now we're not going to need any gems or anything special, so let's give a click on Rigid Oscillator Test, and then we'll click Set as Default. Once that's wrapped up, we can close the project configurator. Once we've got our project set up, pop open an administrative command prompt and let's get to our Lumberyard install. Traverse into the dev directory, and what we need to do is run lumberwaf configure. So that is lmbr_waf.bat space and the word configure. Press enter. We'll let that roll. I'll meet you back when it's done. Alright, that's done. The reason we run that lumberwaf configure is so that it can generate a Visual Studio solution for us. So you'll see here one of the last lines it shows creating this .sln file. It's what we're going to be using in Visual Studio to actually edit this code. So make note of where that is. We're going to pop that open in just a sec. Alright, I've popped open Windows Explorer. I've jumped into my Lumberyard 1.8 install into the dev directory. Next, I'll want to go into Solutions, find this .sln file, double click it to pop it open in Visual Studio. We'll let that load up for just a sec, and I'll meet you back when it's done. If you caught the empty component videos, the next couple steps are going to be very familiar. What we need to do is over in the right-hand Solution Explorer, expand out Game, find the name of our project, expand that out, expand the project that's in there. We're going to give a right click on the project, come down to Add, click New Item. That'll pop open the Add New Item wizard. First we'll go to the location, we'll click Browse. Jump back out to Dev, into Code. Again, find our project. Hop into Game. And then same as last time, let's go ahead and right click, come down to New, and we'll add a new folder called Components. And then we'll click Select Folder. We'll start with the header file. And I'm going to name this Rigid Body Oscillator.h. We'll click Add. And we'll do the same thing over again. Right click the project. Go down to Add. New Item. We'll have the location already set, so we'll jump up to CPP. And we'll create the Rigid Body Oscillator.cpp file. Go ahead and click Add there too. Got both of our new files ready to go. Before we get started throwing code into our new files, let's get the housekeeping out of the way. So in the Solution Explorer, let's expand Core. We'll find our project name, game.cpp. Pop that open. What we need to do is add an include for our new header file. So that's include components/rigidbodyoscillator.h. I'm also going to throw one more include in here. I'll explain why when we get to it. That's going to be an include for azcore component application bus.h. Close that off with a bracket. Okay, we've added those two lines. In the same file, let's scroll down a bit until we hit complete init. We'll see a return true there. We're going to add a line here. We're going to use the ebus event macro with AZ namespace component application bus. What we want to do is register a component descriptor and that's going to be our rigid body oscillator its create descriptor function. Now Visual Studio will probably complain because I don't have that function defined right now, but we will. So with that in place, let's give it a look over. Looks good. We can go ahead and save this file and close it up. Last bit of housekeeping is we need to tell the WAF build system to add our files. So we'll close up that core filter, expand the _WAF filter, find the game.waf files file, pop that open. See a couple of arrays in here. What we need to do is make another one. I'd like to keep this alphabetized if I can. So we'll call this components, colon after that, new line, open the braces. And then in here, what we need is components slash rigid body oscillator.h, comma, one more new line, components rigid body oscillator.cpp. Don't forget to put a comma after the close bracket, and we're looking good. Give that a save, close it up. Okay, we're ready to add new code, so let's start with our header file. We'll get typing, and I'll try to explain as we go. First line is just going to be a pragma once. That makes sure we don't include source more than once. I'm going to keep the comments in this pretty light. In the final version that I will post a link to at the end of this video, I'll have commented up the code a bit more, but I don't want to drag this out too much, so I'll keep the comments pretty brief here. There's going to be a couple includes just for component stuff. So that's the entity header file. Would you believe that's the component header file? And then last, we need the component bus. So that's in AZ core, component bus. All right, I'm gonna need a couple more buses. So one more comment. We'll start with the transform bus. That'll become apparent later on when we're editing the C++ file, but I'll talk about it when we get there. So that's transform_bus.h. We also need, let's see, the entity bus. And then one final include, and that's going to be in AZ core like everything else. But this one's going to be in the math. And that's the transform header file. That'll make doing some math on transforms a little bit easier on us. So that's all of our includes. So now let's start with the actual class definition. I'm going to namespace this to ly game. And we'll define our class as rigid body oscillator. It's going to be a child of AZ components because it is a component, and also of The transform notification bus handler. We're going to subscribe to the transform notification bus to know when the component entity we're attached to has moved. So that's going to be really important for us. So let's move along. Another open brace, and we will define some public functions and whatnot. First is going to be our destructor. That's going to override its parent class. We're not really going to do anything special there, so we'll just leave that at default. Use the AZ component macro and put in rigid body oscillator. And then what it's going to want is a UUID from us. Windows doesn't make it particularly easy to generate UUIDs, but if you pop open PowerShell and then type open brackets, GUID, close the brackets, 2 colons, new GUID, like that, it'll spit one out. And that's as good as any. So I'll select that, right click, that'll copy, close that up. Paste it in. Looks good. Semicolon on the end of that. And we'll keep moving. Next, let's put in a line for the reflection. Static void. Reflect. If I could spell, I would spell reflect. That's an AZ reflect context. We'll call that reflection. You'll see that in the source code. Sometimes that's reflection, sometimes it's something else. I like to stick with reflection. Then we need a couple more AZ component functions to override. So those will be init, activate, these all have empty initializers, and deactivate. Actually, I can pop that off entirely. Should take care of the component stuff we need. Since we're going to be listening for transform changed events, let's throw in a forward definition for that. So that's on transform changed. We're going to need a const transform. And then another const transform. One last forward definition in here. This will just be a function I'm going to write in a little bit. We'll just call this impulse up. It's not going to take any arguments. That should wrap our public bit. So let's move on to private. In here, we're just going to dump a couple of variables that we'll use in our C++ file. So let's start with a float. We'll call this oscillation radius. We'll set it to 1. Make another float. We'll call this one oscillation force. We'll set that to 10. We'll set a Boolean for oscillation enabled. And we'll set that to true by default. And then we'll grab, say, 2 transforms. Call the first one entity transform. We'll call the second origination point. How about that? So that should be our header file done and dusted. Again, I'll include this. Oh, look at that, I misspelled override. All right, glad I gave that a once over. Like I was gonna say, I'll include this in the bundle at the end of the video with the link and all that stuff, so don't feel time bound to type this out with me. Just wanted to talk through it as I typed it out so that I can at least a little bit elucidate what it is happening here in the header file. Jumped over to the C++, and we're going to start much the same way we did last time, and that's with includes. Again, we got pragma once, and because we're running Visual Studio, the first one we'll see is stdafx.h. Moving on from that, we'll include the header for our rigid body oscillator. And then we're also going to do an include for math conversion. We will include some more stuff from AZ Core, notably serialization stuff, so that's going to be serialized context. And from the same namespace, we will grab edit context. Those will both become apparent in a minute. And this line, I'm loath to do this. I know this is terrible. Never do this in production code, but for a proof of concept, it'll be fine. We're just gonna do this one by its path, because I can't quite figure out the namespace syntax on it. And that is the physics component bus. There's got to be a better way to do that. I tinkered with it for a bit, and I didn't want to burn a whole lot of time. So, like I said, this line 9, never do this yourself. For this test, it'll be good, but figure out how it actually works, please. Moving right along from that embarrassment, we'll open up the namespace. That's going to be that ly game. And our first function is going to be the rigid body oscillator reflect. It's going to take reflect context, reflection. This one's going to take quite a bit of typing, so let me jam it in, and then we'll kind of walk through it line by line and talk about it. All right, there we go. So this is all the serialization code that is responsible for exposing our component to the Lumberyard editor and for allowing the user of this component to change certain parameters. So up here, lines 18 to 22, we have the fields that we want to expose to the editor. That is the oscillation radius, the oscillation force, and then that Boolean oscillation enabled that we defined in the header file. We've got those serialized to the context there, or added to the serialization context, I should say. And then down below we have the edit context. Now this is where we set certain parameters around what the editor is going to expose to the user. So we have a short description of what it is we've created, the rigid body oscillator. Slightly longer, more descriptor there. I'm going to add it to the physics category in the component palette. I'm going to steal the icon from the rigid body physics component just for fun. So there the icons are. And then what we've got is our data elements. Now this, again, correlates up here to the stuff we've added to the serialization context. We've got the oscillation radius, got a minimum value of 0, steps are 0.1. We've got the oscillation force with the same deal, and then you'll see here, the bottom one, given that this is just a Boolean, we don't need to add attributes to that. The editor will generate a tick box for us. So that's the reflection bit done and dusted, so we can move on to activation and all of that. Let's start our activation function. First thing we want to do is subscribe to the transform notification bus. come down, we'll find that. And we'll do that with the bus connect. We are going to subscribe to the transform notification bus for the entity to which we're attached. And then we're going to set the origination point equal to the transform create identity. Should add there are more elegant ways to do this. I just want to show code getting entered and kind of basic bus interfacing here. I think in the next video what we'll do is we'll create two new classes, one that actually sends events out on an event bus and another one that actually subscribes to that event bus and listens for those events. But let's just get this going. After that, I'll use the ebus event ID result macro with our origination point. Again, that entity is going to be our entity. On the transform bus. Get world TM looks good. That should do it for our activate function. We are good to move on to deactivate. So we forward declared these in the header file to override the basic component functionality so that we could put stuff like that, or like what we've got here, in. So for deactivate, all we really need to do is make sure we disconnect from that transform notification bus. So to do that, we just call, would you believe, bus disconnect. Actually, I think I forgot the handler. Yes, I did. There it is. Bus disconnect. It should be all we care about for cleanup here. So that is activate and deactivate, all done. So we're subscribed to the transform notification bus, and what that'll do is every time the transform changes on our entity, it's going to send a notification. Right now we're not handling that, so let's go ahead and do so. We're going to do that on the onTransformChanged function. And like we saw in the forward declaration in the H file, the header file, that's going to output two constant transforms. That's going to be const az transform. We'll call this one the local transform because that's what it is. And then the second const az transform is going to be the world coordinates. So in here, what do we want to do? First, let's set our local variable, the entity transform, equal to the world coordinates. And then let's think about how we want this to go. If we're going to have this object oscillate, the first thing we need to do is make sure oscillation is enabled. So we'll start with an if. Because it's a Boolean, all we really need is if oscillation enabled. That will evaluate to true if the Boolean is true. And if that's true, we want oscillation to happen. All right, it's confession time. I never took physics in high school or college. The one physics-ish class I took was astrophysics. So this is going to be a gnarly hack. I'm not going to calculate gravity or figure out kind of where in the arc we are. I really just want to give this thing a little shove if it reaches a certain point. That's what we're going to do. Like I've said ad nauseum, there are more elegant ways to do this, but this should get the point across and be fairly straightforward. So let's say if the entity transform, all we really care about, well, first we got to get the position. That's a function, of course. All we care about is its z coordinates, so we can say get z. We'll say if that's less than our origination point. Again, we need to get position on that transform, and we still only care about z, plus our oscillation radius, which we've got defined as m underscore oscillation radius. So if our current z position is less than the origination point plus the oscillation radius, what are we going to do? Well, we'll call a function we haven't defined yet, so this is kind of cheating. But what we'll do is we'll make a call to rigid body oscillator impulse up. So, like I said, cheating. It's not going to oscillate perfectly here, but it will do kind of what we want it to, and that's all I really care about for this. The last things last, all we need to do is define this impulse up, and we'll do that next. So if our transform is below a certain threshold, we want to give our component entity a shove in the right direction. That's going to be straight up. So let's define a function. That's going to be rigid body oscillator impulse up. Takes no arguments. More braces. So we're going to define a vector 3, and we'll call it force to apply. We're going to calculate the force we want to apply and then apply it. And we're going to set the z force to our oscillation force. So the user can define a force that they want to impart on the object, and this is where we're going to set that. And we're going to use the struct that's defined in the physics include, I believe. It's PE action impulse. We'll call ours impulse to apply. And we'll set its impulse to a Lumberyard vector 3, different from an AZ vector 3, our force to apply. So now we've, in a really roundabout way, defined the impulse that we want to apply as a vector 3, and we need to tell Lumberyard to impart that impulse on our component entity. Again, we will revert to the event bus macro. That brings up a good point. This macro, I believe, is being phased out for a more kind of verbose, more straightforward, in a way, manner of accessing the event bus. And I'll show that off in the next video. Given that this is a cryphysics component, I'm not entirely sure if I can access it in the quote-unquote new way, so we'll just use this for now. We need to get entity ID. It's going to be our entity. Cryphysics component request bus. We're going to apply a physics action. And that is going to be impulse to apply. Now see, that's kind of poorly named, and that is not thread safe. So here what we're going to do is put an event on the event bus to apply our impulse. I think that is going to be it. So let's double check, do a quick scan. I may have made a boo-boo here or there, and the compiler will sure tell me about it. I'll package this code up with a header file, like I said earlier, but let's give that a save. Then let's try to compile. We'll see where we go. Just scanning through this, I did see one error. I don't want get entity, I want get entity ID there. That makes event ID happy, no more red squiggles. Save that again, and now we will try to compile it. Now, it's kind of a pain, but the first time you compile your new component, the compiler and Visual Studio are going to get a little bit angry at you because Visual Studio is going to create new filters for your component and all that. So generally the first time around, it's best to just close Visual Studio, save all of this, and once that's gone, we can pop open our administrative command prompt, CMD, hold Control and Shift, press Enter. You won't see the UAC prompt, but it's there. I click Yes. Jump into our Lumberyard install. Into dev, and what we want is lmbr_waf.bat. Then the ever-present build win x64 vs. I'm going to use 2013 here. If you're using 2015, do that. Profile -p space. I usually do all. I have time on my hands. What can I say? I press enter. That's going to take a while. I'll meet you back when it's done. Hopefully not with a sea of red. Ermagerd. Finished successfully. So that means I either forgot to include something or God only knows what, because I'm never lucky enough to have this work first time out. But let's hold out some hope. We'll pop open the Lumberyard editor and give it a crack. Editor's open, so let's create a new level. We'll call this level 1. I don't need a whole bunch of play space, so let's notch that way down. Click OK. We'll leave texture dimensions where they are. Click OK there. Let this scene load up. Get rid of all of our debug info. Let's notch that console down just a bit. Back up the camera. So let's create a new entity. And now's the moment of truth. Let's see if our component is there. So let's click Add Component. Come down to Physics. There it is, Rigid Body Oscillator. Give it a click. You can see the 3 parameters we chose to export or to reflect to the Lumberyard editor. We've got our oscillation enabled checkbox. We've got our force defaulted to 10. We have our radius set to 1. This is an auspicious start. So let's leave off our rigid body oscillator for a second, and we'll add some stuff to make this thing visible. First, we'll grab a sphere shape, and we'll set its radius to, say, 0.5. Then we will come down to rendering. We'll add a static mesh. And then we'll click Add Component one more time, come down to Physics, and we'll give it Rigid Body Physics. Good, good, good. I believe that's all we're going to need. I take that back. Let's give it a collider as well. So Add Component, Physics, come down to Colliders. We will give this a Mesh Collider. So on our component entity, let's come down to Static Mesh. Let's give it an asset here. So we'll click the triple dots to the right of Static Asset. We'll jump into, say, Objects, into Default, find the primitive sphere, and we'll click Open. You can see it kind of popped in there. I'll zoom in on it a bit. Texture not found, not very appealing, so let's give it a material override. Click the triple dots to the right of Material Override. Jump into Materials, into PBS Reference. And let's say Rusted Metal. Click Open. There we go, a nice rusty sphere. I'm going to hit 2 on my keyboard and just kind of shove that up into the sky a bit. Looking better already. Why don't we rename this entity to Oscillator, so we can keep it straight in our heads. And then let's, over in the entity outliner, click our oscillator. We'll right click it, We'll duplicate it. We'll name this one rigid body. And then we'll take our duplicated guy and we'll just shove him kind of over here so that he's in our view. We'll take the X and shove it back there a little bit. So we've got our oscillator in the foreground, our rigid body in the background. We'll change the material on that guy too, just so it's a little bit more obvious. Now we should be in good shape. Actually, while we're here, with our rigid body selected, let's pull our rigid body oscillator off of this guy. So we'll right click rigid body oscillator, click remove component. All right, now we should be in good shape to give this a test. One last thing before we do test on both of our component entities. So let's start with the rigid body. Down in rigid body physics, let's untick at rest initially. Jump to the oscillator. Do the same thing. Then on our rigid body oscillator, let's set that oscillation radius to say 5. And let's set the force to maybe 20. See what that looks like. We'll also shove this guy up just a bit there. All right, moment of truth. Out in the perspective viewport, let's give a click. Shove our console down even further just to give us more space. Let's press Control G. Well, that was underwhelming. This one did look like it was falling a little bit slower. I think what we've got here is that our oscillation force might not be enough to overcome gravity. So let's crank that, let's say way up. We'll say oscillation force is 2000. Out in the perspective viewport, let's press Control G again. That was better. They're going to come back down. There it is. Ah, we see it turn around. All right, we're making progress. Let's try to hone that value a bit. Maybe 200 will work. Again, Control G. Up. Down. Hey, we got it. So as you can see from those fits and starts, both 20 and 2000 totally break the setup because it is so flimsy. There's just that single kind of if check. That's not production quality by any means, but we do see our component entity oscillating upwards and downwards. If I'm right, it'll probably end up kind of oscillating toward that point we've got as our inflection point and then eventually stopping. But what we've got is the transform is changing basically on every tick, and that's firing an event on that event bus that we're subscribed to. We're listening. We're checking to see if that transform we're getting is above or below our threshold. If it's below that threshold, we're applying an impulse, that 200 number, on our object, straight up the z-axis, which is shoving it back up into the sky. So if we wanted to, we kind of angle the camera down. Let's set this to something absurd, maybe 4,000. What we should see is this thing just take off like a rocket. And there she goes. Like it just about hit its apex. Actually, there it comes, coming back down. Now it's going to hit that threshold again. It's going to pick up our force. It won't bounce as high this time because it had all that downward momentum that we're kind of sort of canceling out with our impulse up. But you can see we're interacting with physics with a component that we built ourselves. I'd say that's a win. So as we watch our rigid body oscillator oscillate this guy up toward the heavens, that's all I have here. I'll throw an annotation on screen, kind of where our object is floating right now, with a link to a zip file that's got the C++, the header, all the bits you need to do this yourself. Hopefully you can follow along. Like I said a couple of times here, this is not production level code by any means. Feel free to use it if you want. It's got some great basics as far as extending the empty component we looked at last time. The serialization stuff is all pretty solid, but the actual physics work here is just nonsense. But I did want to show how we connect to an event bus in C++, what we do as far as responding to the events that come out of it, and kind of have some fun with popping an object up in the air. As always, don't forget to like, subscribe, join the Lumberyard Slack community. Links and descriptions for all that down below this video. I have been Mr. Toolbox. I appreciate your patience. I hope you got something out of this. Do let me know down below this video one way or the other, because I'm going to keep rolling on this C++ train. I am entertaining the hell out of myself doing things like this. Even if you're not particularly entertained, I haven't heard any complaints yet. So I'm going to keep rolling on this train until I hear otherwise. Anyway, that's all I got. Bye.